Here we go. We are going to do more with logarithms, obviously. This whole thing's about logarithms. But you even had this on the quiz. Remember when you had some problems where you could get the base to be the same? And I don't know, do you have... I'm trying to think of one off the top of my head where you could get the base to be the same. Let me just look on this thing right here. Nope, that's not the one. That's okay. We reviewed that. I can't think of one off the top of my head. I don't have one right in front of me. But you remember when... I'll tell you what, when we had this. This is just a super easy version of it. But if you had the bases the same, what'd you do? You just set the exponents equal to each other. But there are times, though, where you cannot get the bases to be the same. All right? These were all rigged. Did you understand that? They were rigged so that you could get the base to be the same. I mean, the person who figured out the problem said, I'm going to make this so both the bases are going to be 3 or both the bases are going to be 2/3. Remember the quiz yesterday? It could be a fraction and that kind of stuff. It was all rigged. But now, here's a problem where the bases cannot be written to be the same. So look at this. 7 to the x equals 12. We want to find what x is equal to. Now let's think about what we're actually doing here. Let's not just learn just how to do it. Let's understand what we're trying to solve for. We're trying to solve for an exponent here, aren't we? It's trying to say 7 to what power is going to be 12. Well, let's think about it. What if x was 1? 7 to the first. That's what? 7. So it's got to be a little what? Compared to 1. It's got to be a little bit more than 1, right? Let's go 2. What about 7 squared? What's 7 squared?
49.
It's 49. Wow, that's 49 is way too big. So it's got to be somewhere a little bit closer to 1. A little bit bigger than 1, but down in the lower range. Is that what we do? So we just try a whole bunch of numbers and see what works? No.
Yeah.
Watch what we're going to do here. You could, actually on this one, now that I'm thinking about it, you could do it 2 ways. Let me see. Let's do it the old way, and I'll show you a new way to do this. You could, this is exponential form, so you could change this into what? In a logarithmic form. So let's do it. This is old. So log base what? What's our base here? 7 of what? Of 12 equals x. So you could do this. And then, let me bring the calculator up. You could put this into calculator. What theorem do we use? Remember what name we gave it? Change of base theorem. Do you remember that? So let's do the change of base theorem, and let's see what we get. So remember how to do this? It's log of what? Right. The bigger number, not numerically, but the one that's bigger than this one right here. So that's 12, log of 12. Remember, this is a common logarithm. Remember, the change of base theorem is a common log, so it's log base 10. So that's why they call it the change of base. We're changing it from base 7 to base what? 10. No, to base 10. All right, because just that log button, when you push a log button on a calculator, it's automatically programmed where it's base 10. So it's log 12 divided by, then what is it? Log 7. Good. And you guys just had that worksheet, right, where you did a whole bunch of those and you got them all right. Okay, so that's not hard at all. So go log 7, all right, and then hit equals, and there it is. Just like we said, it's a little bit bigger than 1. It's probably not closer to 2, is it? Because 7 to the second is 49, so it's probably a little bit in the lower range, and that's what we have. About 1.2769 or whatever you want to round it to. That's one way to do it. All right, you could do it like that. What did I say it was? 1.27 something? Whatever, we'll just go 2 places. But here's another way to do this problem. I'll just write the problem out again. And this is one, you're not always going to be able to change these problems from logarithm or exponential form to logarithmic form. You might need another way to do this, and this is what we're going to do. This is a simple problem, but we're going to do this another way. Watch. Do you remember in algebra, what's one of the major things? It's one of the first things that you learn in algebra, like algebra 1. About doing stuff to both sides. What did you learn in algebra? Whatever you do to say, that's right. Whatever you do to one side, you do to the other side. So same thing here. And what we can do is you probably never thought about this, but we can actually take the log of both sides. All right, as long as there's the same base. Now, since we know base 10. All right, it would be easy just to put a log there. You don't even have to put a base, do you? We'll just use log base 10. Plus, you can use log base 10 in your calculator, which is kind of nice. So watch this. Watch what I'm going to do. I'm going to take the log of both sides. So it's log of 7 to the x equals what? Log of 12. Now, you could go natural log as well. It would still work with the natural log. In fact, now you don't have the book in front of you, but the book actually uses the natural log. It would work either way. And watch, just for fun, let's do it. I'll leave some room. Let's go natural log of both sides, and we'll put them both in, and I'll show you. You get the same exact answer, whether you use the natural log or the common log, which is log base 10. The key to this is to use a logarithm with the same base. Now, since I have a calculator, and my calculator only has two bases in it, it's got log base 10 and log base e. Alright, so I'm going to use either one of those. If you just want to use the regular log base 10, that's fine. If you like that natural log, you think it's cooler looking, whatever, right? You want to use that, that's fine as well. So anyway, what do we do here? What can we do? Now, putting logs here, how in the world did that help us? Well, I've got this. This is an exponent, and I've got a log out in front. We've done this step plenty of times. What do we do with this exponent? Good. Put the x out front. Very good. So let's write it x log 7. Remember, it's log base 10, but I'll just say log, and this is log 12. You with me on that? Now watch. Log 7 is just a number you put in your calculator, isn't it? Log 12 is just a number you stick in your calculator. What are you trying to do here? Trying to solve for x. So if this is just a regular old number and it's being multiplied by x, how do we get rid of it? Divide. Good, we divide it. So we divide this side by log 7, divide this side by log 7, and check it out. It's the same thing as we had here, isn't it? Okay, because what did we do on our calculator? I didn't write the step in, but what did we do? We went log 12 over what? Log 7. Look what happens. It works out to be the exact same thing, doesn't it? All right, you're not impressed by that? So that cancels out, and then you just put that in your calculator. We already did it. It's like that 1.27. What's really impressive is this. We can do the same exact thing with the natural log. As long as we know that the bases are the same, we can take the log of both sides. All right? So we could do this as well. Do the same step. The x goes out in front, so it's x natural log of 7 equals natural log of 12. Divide both sides by natural log of 7. We'll just do it like this quickly. Watch what x is equal to. X is equal to that. Now it's natural log. You're like, yeah, but it's not going to get the same answer because it's natural log, and we used common log before. Well, let's see what happens. I'll keep that up there so we can see it. Let's go natural log of 12. So watch, ln, that's natural log of 12, divided by the natural log of 7. So ln 7, and then watch what happens. Do you think you'll get the same thing or not? Yep, look at that. Same exact number, isn't it? So it doesn't matter if you use the common log, just log, or you use the natural log. As long as the bases are going to be the same, you can do it this way. All right? So that's what you would do. Now that's how you could do this two different ways. All right? If you wanted to change that to logarithmic form and use the change of base theorem, that's fine. I got no problem with it. But this is just an introductory problem to show you that you can take the log of both sides. All right? And there are times where that's the only thing that you could do. There are times when you just can't change it to exponential, or from exponential to logarithmic form. Sometimes you have to take the log of both sides. Now, why do we do this? Because there's no way I could write 12 with a base of 7, is there? All right? So you looked at this and you're like, well, that looks kind of familiar. We kind of did this stuff before, right? For instance, if I had 2, now I can make this up in my head. Now I'm thinking a little bit straighter. That's all the blood rushing out of my body probably from giving blood. So watch, 2 to the x equals 8. We could have done this. Now this is rigged for you, isn't it? This is what we talked about earlier. What's 8? It's 2 cubed. So what's x equal to? X equals 3. Now you could do that with this one, couldn't you? If you wanted to, if you really wanted to, you could do that whole logarithm thing. Let me just show you how it works. Let's stay on the same page, but let's go to a different color just so it stands out a little bit more because I got so much writing on here. Watch this. Let's do 2 to the x equals 8, and let's do it the way we just learned it. What can we do to both sides? Now we know we could just keep, the bases the same, but let's just for fun, let's just do it this way. Let's take the log of both sides. So it's the log of 2 to the x equals log 8. And let's take that x and put it out in front. That's the power rule. So it's x log 2 equals log 8. And let's divide by the log 2. All right, so log 2. And let's punch that in our calculator and see what we get. Now it's kind of a wasted effort because this would be way easier, wouldn't it? Doing that thing right there, that's way easier than going through this stuff. But I'm just showing, just trying to prove a point to you that it still works. Okay, so let's go log 8. Again, you could use natural log if you wanted to. It doesn't make any difference. So log 8 divided by log 2. Remember, it's common log. And then equals, check it out, it's 3 right there, isn't it? Okay, just like we got up here. So it just kind of proves to you a little bit that this thing really does work, right? We knew it should be 3, all right? And sure enough, you do it this way, it comes out to 3 as well. Does it make sense? All right, let's go to one more.